Alright, this video is just a brief introduction to sequences. So a sequence is just a set of numbers that are written in a specific order, so there's some kind of pattern to them. We're going to reference what are called terms of a sequence. The terms of a sequence are, if I want to know what the third term is, I want to look for the third number in the sequence. And then we are going to start to write formulas for them, or be able to find the terms given the formula for the sequence. Okay, so here's an example. The function for the sequence 2, 4, 6, 8, 10, so on can be written as a sub n equals 2n. So what that means is if I plug in 1, I get 2. If I plug in 2, I get 4. If I plug in 3, I get 6. And so we're writing a formula that's telling us if I want to know the nth term, whatever that is, I plug in that number, and that would give me the value of that term. So we're going to have to look for some patterns, and we're going to need to know what some of these little formulas are to represent those patterns. So 2n will give you a sequence that is all the even numbers. Alright, so here we're given a formula. We just want to find the first 5 terms and then also the 100th term. So a sub n equals 2n minus 1. So if I want to know the first 5 terms, I just want to plug in 1 through 5. If I plug in 1, 2 times 1 minus 1 is 1. If I plug in 2, that's going to give me 3. If I plug in 3, I'm going to get 5. If I plug in 4, I'm going to get 7. And if I plug in 5, I'm going to get 9. So there are the first 5 terms. The 100th term, if I plugged in 100, I would have 200 minus 1, which would be 199. So if you look at your pattern, these are all the odd numbers. So keep in mind that anytime you need to reference, hey, these are all the odd numbers, we're going to use this 2n minus 1 to represent all odd numbers. And again, 2n represented all the even numbers. N squared minus 1. So this is all of the perfect squares minus 1, right? So if I plug in 1, I get 0. If I plug in 2, I get 4 minus 1, which would be 3. If I plug in 3, 9 minus 1. Plug in 4, 16 minus 1. And if you plug in 5, we're going to get 25 minus 1. If you plug in 100, that's going to be 100 squared minus 1. So n squared represents all the squared numbers. The minus 1 is just taking 1 away from that. But n squared is a pattern that you may use to represent all the perfect squares. Next one we have n over n plus 1. So if I plug in 1, my numerator is 1, my denominator is that plus 1. So it's going to be 1/2. If we plug in 2, we're going to get 2 on top, and on bottom 2 plus 1, which would be 3. If we plug in 3, 3 on top, and the bottom would be 4. Plugging in 4 would be 4/5, and plugging in 5 would be 5/6. A lot of times when you find these first 5 terms, you're going to be able to find a pattern that you can go with to get the rest of them. So the 100th term would be 100 on top, 101 on bottom. And then the last one we have negative 1 to the n over 2 to the n power. Now there are a couple things here that are going to be useful for when it comes to writing these equations. On top, negative 1 to the n. So if I plug in 1, negative 1 to the first is negative 1. And on bottom, 2 to the first is 2. If I plug in 2, negative 1 squared is positive 1. And 2 squared would be 4. 3, negative 1 to the third power is negative 1. And 2 to the third power is 8. Negative 1 to the fourth power over 2 to the fourth power. And negative 1 to the fifth power over 2 to the fifth power. So what I want you to see here is on top, I want you to notice that these signs are alternating. Negative 1, positive 1, negative 1, positive 1, negative 1. And that's just determining how many of those negative 1s are multiplied together, right? So anytime that you see a sequence where the sign is alternating, right, from a negative to a positive to a negative and so forth, use this -1 to the n power. That will help you to alternate sign. And then on bottom, 2 to the n. 2 to the n is just giving us all the powers of 2, right? 2, 4, 8, 16, and so forth. If I noticed that they were all the powers of 3, it would be 3 to the n, and so forth. So anytime that I notice, hey, these are all the powers of whatever, that's what I'm going to use to represent that. Okay, so the 100th term, -1 to the 100th power. Well, that's an even number of -1, so I know that's going to be +1 on top, and on the bottom we're just going to have 2 to the 100th power. That's going to be a really big number, so I'm just going to leave it as 2 to the 100th power. Okay, so just using these formulas to find the first 5 terms, or any specific term. In this case it was the 100th. But this is going to lead into some videos where we look at the pattern of the sequence and we try to write the formula that gives us that sequence.